Hello everyone, here Dr. Shah. Today I am going to show you animations using Creo software how a suspension system in train railway behaves when load acts over the spring. So here we are having frame structure. You can see here frame structures, and a spring is sitting in between the body weight, body weight and frame structure. So three parts are important here. One is the spring, and on the top it is sitting is booster weight we say, and bottom one is the frame structure. Okay, so we will simulate with the help of simulations. So go to the simulation, start Creo software here. Okay, so here I am using Creo 12. Choose one plane. I have chosen this one. Go to a sketch, view mode on, draw a rectangular or base frame structure I am drawing. I am giving dimensions 200, all in mm. Width say 100 I have given. Rectangle created, extrude it. So we need thickness of 25 frame structure thickness we need. So this part completed, frame structure. Now next what we need is to make a spring. Okay, so choose this plane, sketch. Okay, so you can choose any of the plane. Okay, here over this frame structure we will create a spring. Length how much we need, say this much length we need, so we will give dimensions up to how much long length of a spring we need. 100 mm I have given. And what should be the radius of the spring? This I have given 25. Okay, now provide a center line. So around this center line this spring will be created. So click OK here. So in 3D view the image will be seen something like this. Now next what we need is to make a spring. Go to helical spring. We have to create a circle of small d diameter of a spring. Sketch, then go to sketch view. So where we need here small circle. Say of what diameter I need spring. The diameter of the wire of the spring say I have given is 25 too big. So to give 5 will also be too long. Let's I have given 5. 3 I have given. Okay, you can change later on also. Okay, so once you have created circle over here, starting from here, click OK. Now see, spring has been created. You can change the diameter. So if you need, you can then after use this left-handed rule or right-handed rule of this plane. So I have, by default I have taken right-handed rule. Pitch also you can change here. Say the pitch is 10 right now. You can increase or decrease the pitch. Say 5. So distance between the two consecutive is known as pitch. So a dense structure you have created. Say 7.5 I have given. Pitch. Okay. Click OK. Now if you have to change the diameter of this wire of this plane, then right click over here, sketch. Okay, edit dimensions. Okay, edit dimensions when you will do. Okay, that was okay. Go to here, edit dimensions. So pitch add one reference 7.5 pitch add okay. Full frame over here edit definition. Okay. Okay. Sketch. Okay. Here you can change the diameter of the wire. Say I am increasing the diameter 3.5. Okay. Or you can increase say up to 5. Okay. So that is okay. So on above this spring I have to place poster weight. Okay, weight of the bogie I have to place. So how we will do this? Select this plane, sketch this one. Okay, now what we need, you have to pass a axle or draw an axle. So use this reference tool. So I have to touch this one. Okay. Twist this portion, and then after use this one, then I should use this one. Sketch glue on. Then you can use this lips. So say for example I get the center over here. Okay. And all this touching over here, you can see. Okay. That's it. So ellipse I have created. Press escape to last dimensions. Okay, this much minor diameter of the ellipse I have provided is total is 50 I have given, and this much major axis distance I am giving is 250. Okay, now remove the remaining extra portion from using this tool. So we have achieved like this. Click OK. Okay, now again we will be using sweep command. This sweep. Okay, now a rectangular portions I will create here. Sketch. Now a rectangular portion it is asking to draw here. Sketch view. Okay, create a rectangular portion over here. Okay, give proper dimensions. Say width I have given is 7.5 and this height of the rectangular plate I am giving is 15. Okay, this I have drawn. Now click OK. Shift command has been done. Okay, click OK. Use this view. Suppose these portions I am keeping like this. These portions I am okay, that's okay. Now modeling part I have done. Now what next is we will be axis display. Okay, now plane I have removed. Now we will go to live simulation. Fixed the bottom portion of the frame structure. Okay, I have fixed. Now I have to provide load over here because poster weight or body weight is acting over these two surface small portion. So go to force and provide see the coordinates over here. When I am providing force from top to bottom, this is z na, so going downward means minus z. So you have to provide minus something whatever the load you are providing. So units I am taking is Newton. Okay, z is the minus say 1000 Newton I have provided in the minus z direction, means downward direction. Okay, now I have to provide select the points surface. This surface, again another one is also left. This surface and this surface. Control, then both the surface will be selected in the minus z. If I will provide plus or simply, then means expansion or extension in the spring is happening. If I am providing minus 100, what does it means? The arrow is showing downward, means compression is happening the spring. Okay, click OK. Now next is the providing the material. What type of material I am using? So for the all the three set parts I am using prepare, model properties, change. Okay, go to standard material, ferrous material. Say I am using here steel. still low y. Okay, click OK, close. Okay, now click this simulate. Will take some time. Okay, now different results you will be getting here. Okay, on the right side contour results you will be getting. See, you will be getting different stress, deformation, stress. In stress you will be getting in different direction stress values, maximum principal stress, etc. Similarly in strain, different strain results you will be getting. Okay, from here animate deformation. Okay, see, if I want to check the results, red one is the maximum deformation happening here. Why it is more red compared to here? Because the contact here is less. In support portion in the right side is more. That's why the less deformation on the right side of the screen. On the left side more red means there is less contact. You can see from the okay. Similarly you can check the stress value also, maximum principal stress. See, at the center of the body where it is acting. Similarly strain, maximum principal strain. Shear strain x minus shear strain y. Reaction results, reflection in mm it is giving. Different speeds you can check the value. As we will change the material type, we will be getting different deformations. Okay, that's all side. Okay, thank you all.